Hello and welcome back to what is for now our last stop on our journey to all of the bodies of our solar system. We've covered all the planets, the dwarf planets, and the major moons. So what about the asteroids? Actually, we have talked about one, the OG asteroid Ceres, which is now classified as a dwarf planet. But what about the rest? Well, there's actually over 1 million of them that we know of. First, let's clarify that asteroid is actually not an official classification. Prior to 2006, asteroids were classified as minor planets by the IAU. Now the official term is small solar system bodies, or SSSBs. So these are all other objects excluding satellites orbiting the sun. So the other here refers to objects that are already classified as either planets or dwarf planets. So SSSBs include asteroids, but they also include comets and meteoroids. So what's the difference? Generally, a comet is icy. This means that it has volatile materials that will sublimate if it gets close to the sun, and this is what gives comets their beautiful tails. Asteroids and meteoroids, on the other hand, are rocky, which means they're pretty much only found in the inner solar system, the majority being in the aptly named asteroid belt in between Mars and Jupiter. So meteoroids are the very smallest objects, usually considered to be anything less than a meter in size, while asteroids are the rocky bodies that are larger than a meter in size, but not large enough to have become rounded under their own self-gravity, which would make them a dwarf planet. Phew, okay, so now that we know what we're actually talking about, the very first asteroid was discovered back in 1801, and this was Ceres. At the time it was considered a planet, then it was considered an asteroid, now we consider it a dwarf planet. The next was Pallas in 1802, and 1802 was also the year that the term asteroid was coined by the German-British astronomer William Herschel. The term asteroid comes from the Greek for star-like, and this is because asteroids are so tiny that they appear simply as points of light in the sky, just like stars. Of course, stars are very, very large, but they're also very, very far away, and so we only see them as points of light. This is in contrast to something like a planet, which we can actually see a disk. It's more than just a single point on the sky. So asteroids are star-like in that they are single points of light. After Pallas, the asteroid Juno was discovered in 1804 and Vesta in 1807. Unsurprisingly, these are some of the largest asteroids, which made them some of the easiest to detect. A total of 10 asteroids, if you include Ceres, were discovered in the first half of the 19th century. After Vesta in 1807, there was a gap until 1845 when Asteria was discovered, then Hebe, Iris, and Flora in 1847, Metis in 1848, and Hygeia in 1849. Again, these were mostly really large asteroids that were easy to detect. Hygeia is actually the third largest asteroid with a diameter of 433 kilometers. So let's talk about these first four. Well, actually three, because Ceres isn't an SSSB. Pallas was discovered by the German astronomer Wilhelm Olbers in March 28, 1802. He actually found Pallas while attempting to locate Ceres on the sky. So one reason that astronomers had been looking in this location was because for a long while they had thought there might be another planet between Mars and Jupiter thanks to the large size of that gap. So when Ceres was discovered in 1801, they thought that it was that planet they were looking for. But now, just a year later, there were suddenly two. In fact, Pallas, like Ceres, was considered a planet for a while, until the discovery of a profusion of asteroids in the second half of the 19th century, as well as better estimates of their size. Pallas is named after the Greek goddess Athena, who is sometimes called Pallas Athena. And the astronomical symbol of Pallas is a spear or lance in her honor. Now this symbol was used again until the second half of the 19th century when it became too unwieldy to have all of these separate astronomical symbols for the asteroids. They were replaced by a simpler numbering system where they just put the number of the asteroid in a circle based on its order of discovery, so Pallas became 2 in a circle. Pallas is about 511 kilometers in diameter and about 200 zettagrams in mass, which means it actually contains about 7% of the total mass of the asteroid belt. Juno was discovered by the German astronomer Karl Harding on September 1st, 1804. Juno is named after Jupiter's wife, the queen of the Roman gods, and its astronomical symbol was a scepter in her honor, although again, the symbol was later replaced by the number 3 in a circle. At the time, Juno was considered another planet. Now, Juno is about 254 kilometers across, which is very large for an asteroid, but it's still not quite as large as some of these other early asteroids. But its surface is actually slightly more reflective, which makes it as bright as some of the bigger asteroids. And at 28 zettagrams, it accounts for about 1% of the total mass of the asteroid belt. Unusually for these big asteroids, Juno actually has quite an eccentric orbit with an eccentricity of almost 0.25. So it comes as close to the Sun as about 2 AU and as far from the Sun as about 3.3 AU. Now for reference, the Earth by definition is at 1 AU, Mars is just over 1.5 AU, and Jupiter is actually just past 5 AU. Vesta was discovered again by Olbers on March 29, 1807. So Olbers, after discovering Pallas kind of surprisingly back in 1802, thought maybe Ceres and Pallas were both fragments from a planet that had been destroyed around that location. So he was searching for more fragments of this planet. And he found Vesta. So Olbers actually let the German mathematician Carl Friedrich Gauss have the honor of naming Vesta, since Olbers had already named Pallas. And Vesta is named after the Roman goddess of the hearth and home, whose Greek equivalent would be Hestia. Early asteroids were all given female names. I don't know why. Vesta's astronomical symbol was meant to be the sacred fire burning on the goddess's altar. Like the others, this was replaced with a 4 in a circle in the second half of the 19th century. Vesta is the largest known asteroid in both size and mass. Vesta is about 525 kilometers in diameter. This is actually more large as the moons Mimas, Miranda, and Enceladus. Now all of those moons actually are rounded under their own self-gravity. Vesta, however, still has this lumpy, irregular shape characteristic of asteroids. This is because of the composition. So Vesta is actually made of denser materials than those icy moons, and it has more rigidity that resists being crushed by gravity, so it retains its shape. The size at which this transition happens is colloquially called the potato radius. Asteroids tend to look like potatoes. So what the potato radius is actually varies depending on the composition of the materials. Vesta has a mass of about 260 zettagrams and contains 9% of the total mass of the asteroid belt. Between just Ceres, Vesta, and Pallas, that's actually over 40% of the mass of the entire asteroid belt. So you can see that these big types of asteroids are not very common. Most asteroids are very small. Now, after Vesta, searches for more asteroids kept turning up empty. The next asteroid to be discovered, Asteria, was not discovered until 1845 when an amateur astronomer was actually looking for Vesta on the sky. This discovery was actually the first asteroid that was not considered a planet, and it kicked off a new understanding and redesignation of the previous 4 asteroids, similar to the discovery of Eris, recontextualizing our understanding of dwarf planets. And since 1845, we basically have not stopped discovering new asteroids, and we're getting really good at it. We now know of about 1,113,527, and that's going to keep going up. Asteroids may appear star-like in the sky, but they move a lot more than stars do, and so that's how they're actually discovered, by comparing images of the sky at different times and looking for objects that look like stars but are moving. It used to be a manual process, that is, drawing star maps from observations of a telescope and comparing them at different points in time, which kind of explains why it was so hard to discover asteroids at first. This later then transitioned to comparing photographs from wide-field telescopes, which was a step up, but still very intensive. And nowadays, this process is actually normally computerized. CCDs attached to telescopes are used to image the sky at regular intervals, and automated pipelines can be used to stack and compare these images and look for moving objects. This process is considered especially important for the detection of near-Earth asteroids, which are a class of near-Earth objects. The impact of a large asteroid could have devastating consequences for life on Earth, so we kind of want to know if that's going to happen. As of January 2022, there are 27,784 known NEAs, and none of them are in any danger of hitting the Earth anytime soon. And we estimate that we've discovered over 90% of the NEAs that are greater than a kilometer in size, which is really good because these are the most dangerous ones. But we've probably only detected about 40% of all the ones that are 140 meters or larger. So this isn't something you need to panic about, but it is something that we do need to take seriously. And this is why there are various concepts for how we might protect the Earth from one of these near-Earth asteroids if it was going to hit us, including the really cool test mission DART, or Double Asteroid Redirection Test. This is a NASA mission that just launched in November 2021 and is currently en route to the binary asteroid Didymos, and to test how impacting an asteroid can change its trajectory and hopefully, in theory, deflect it away from impacting the Earth. The smaller component of this binary asteroid is about 160 meters in size, and this is the one that DART is going to be impacting. Because the system is a binary, scientists will get really good data about exactly how much its orbit has changed because of the impact. Let me reiterate that this is a test mission. This asteroid that they're impacting poses absolutely no threat to Earth. And in fact, there are no known asteroids that present a significant threat to Earth. The DART impact is scheduled for late September or early October of this year, so keep an eye out for that. So while asteroids traditionally appear star-like to telescopes, we can actually get better images where they don't just appear like dots, particularly by using radar. So planetary radar has actually imaged over 1,000 near-Earth asteroids, which is really cool. But what about exploring them up close and personal? We've done that too. We already discussed NASA's Dawn mission, which went into orbit around Ceres. But first, it actually made a stop and orbited Vesta. It arrived at Vesta in 2011 and spent over a year in orbit around the asteroid. And Vesta isn't the only asteroid that we visited. JAXA's Hayabusa 2 mission launched in 2014 and arrived at the asteroid Ryugu in 2018. Ryugu was discovered back in 1999 and is named in honor of a magical underwater palace from Japanese folklore. Ryugu is a near-Earth asteroid with a moderately eccentric orbit and a semi-major axis of about 1.12 AU. And Hayabusa 2 wasn't just an orbiter. It had 4 rovers to deploy to the surface of the asteroid, although one of them did end up failing. And it took samples. These samples, totaling 5.4 grams of material, were returned to the Earth in December of 2020 and are currently being very happily studied by scientists. NASA has an agreement with JAXA that is actually receiving 10% by weight of that sample, but NASA also has its own sampling mission, osiris-rex. Osiris-rex launched in 2016 and arrived at the asteroid Bennu in 2018. Bennu was discovered in 1999 and was named in honor of an Egyptian mythological bird. The name was actually proposed by a 3rd grader during a Name That Asteroid contest. Bennu is a near-Earth asteroid with a moderately eccentric orbit and a semi-major axis of just over 1.12 AU. Bennu is actually the most hazardous known NEA, that is, it is the asteroid with the highest chance of colliding with the Earth. However, that chance is only 1 in 1750 in the next 300 years. Osiris-rex spent a lot of time observing Bennu in situ, then it collected its sample and headed back to Earth just in 2021, and we are expecting to receive those samples back here on Earth by December of 2023. Some more cool asteroid exploration to look forward to is NASA's Lucy mission, which just launched in November of 2021. Lucy is going to fly by some more distant asteroids that are actually co-orbiting with Jupiter, and these are known as the Trojan asteroids. Lucy will be flying by 6 Trojan asteroids, and along the way, it will also fly by a main belt asteroid. Go Lucy! Also, NASA's Psyche mission is in prep and is preparing to launch later this year to visit the asteroid of the same name. Psyche is a main belt asteroid that was discovered back in 1852 and is one of the 10 most massive asteroids. So yeah, lots to look forward to. I know we've only touched on a few of the million-plus asteroids, but they were pretty cool, right? We'll leave the rest of the details for some other day, perhaps. For now, this is the end of our journey to all of the bodies of the solar system, but of course there's always more to learn, so please consider subscribing and sticking around to learn some more fun space and astronomy topics. It's great to be a galactite. Thanks so much for watching, and I hope you have a good one. Bye!